closed, put phones away. I don't want to see any earbuds. Those need to be away here for just a little bit while we're going through this stuff. Okay, where we left off yesterday, we had already done kind of the, the tough work on this problem. We had this big, ugly inequality with lots of fractions. So we multiplied through by 6, the least common denominator, cleared all the fractions, and we got this inequality, right? Which we solved. We solved by pushing the x's over to the right side, which is fine. We isolated the x, and we ended up with the x on the wrong side of the inequality, right? So I want to really reinforce how important it is when we're solving an inequality. You want to have the variable on the left side. It is about earbuds away, please. I don't want to see any earbuds out. If you got an earbud, put them away. We don't want to have the variables on the right side. It's very difficult to think about how to graph it then. It's just not intuitive. If the variable is on the left side, it's simple, right? We want all the values of x that are less than or equal to. So that's telling us right away to the left of our value of negative 7/18, right? There's kind of a little trick you can do here. As long as the variable is on the left side, if the variable is on the left side, the inequality is creating an arrow that tells you which way to graph. Not that you probably need that hint, but it's there, right? If I wanted to graph this thing out here at negative 7/18 is my endpoint. And what's this telling me then? It's telling me I'm going to have a closed endpoint because of the equals. And look at that, right? We know that a less than, if the variable's on the left, a less than creates an arrow to the left, right? I mean, you don't really have to use that little trick, but it's available, right? You always want the variable on the left. Okay, so what would our other option then be? How could we get the variable on the left to start with? Let's just show we get the same thing. What would I do if I take the same inequality that we just solved? Yeah, I'm just going to move the x's to the left side. So I'll just subtract 15x from both sides. That's going to give me negative 18x minus 5 is greater than or equal to 2. What are the two steps in order, everybody, to isolate that x? Add 5 and then divide by negative 18. Okay, so we add 5. Those guys go away. We're left with negative 18x is greater than or equal to positive 7. You guys all told me divide both sides by negative 18. So those cancel. That's good. What do I have to be careful about here, though? I got to flip the sign. I divided both sides by a negative, which means I've got to flip that sign around. And we end up with x by itself is less than or equal to, how would I write that fraction? Positive divided by a negative is what sign for the fraction? Negative. Where do I want to put the negative sign? Bottom is not good. Where should it go? Could go out front. That's probably the best. Where else could it really go? On top. We'll put it out front, and we'll just think of it this way. We're going to find the sign of the fraction. Positive over negative gives us negative, and the fraction is 7/18, which I can't reduce. Okay, good? All right, so everybody real quick, go to the boards and do 3 things. Solve the inequality, so write it as an inequality, graph it, and write it using interval notation. Go. All right, so we'll go through this pretty quickly. What if the algebra is pretty easy, but let's remind ourselves, how do we deal with this answer? It's gonna be a weird answer. So I cannot point to a single x here, right? So I've got to simplify, which would mean what? Distribute. So if I distribute the 4 on that side and the 16 on that side, that's going to give me 48x plus 16, right? Is greater than 48x minus 160. Still, I can't point to a single x. So what does my next step have to be? Okay, what's that mean? Like what algebra step am I going to subtract 48x? Agreed? I can't have, and think about why that is. I cannot have multiple x's. I have to have either one x or no x's, right? No x's is okay. In this case, that's what happens. When I subtract 48x from both sides, all the x's go away. So now think what that meant with equations. If we solved an equation and the variables dropped out, that was the math god's way of saying it doesn't matter. It does not matter what the value of x is, right? So this is insensitive to the value of x. It doesn't matter what x is. What does this imply? If we get 16 is greater than negative 160, is that true or false? True. It's true. So if it doesn't matter what the value of x is, we get a true statement. What does that mean? What's my solution? All reals, right? Put those two ideas together. It doesn't matter what the value of x is. It's always going to be true, right? So doesn't that mean that this is an identity and that any real number would work no matter what I plug in? It's always going to make this true, okay? Compare that to something like this guy. Again, same kind of thing. I've got multiple x's, so I've got to distribute and combine like terms. So that's going to give me 6x minus 4 less than or equal to 3x minus 12 plus 3x. If I combine the x's on that side, I get 6x minus 12. 6x minus 4. What's my next step? Subtract 6x, which I could even show by just doing that, right? I'm just going to subtract that away from both sides. And the x's go away, so it doesn't matter what x is. What's the outcome always going to be? True or false? That's false, isn't it, right? Negative 4 is not less than negative 12. Because that's false, it doesn't matter what x is, I'm always going to get an untrue statement. No value of x could ever make this true. And so, oh boy, of course. 5 seconds away from finishing. What did it do? There it is. Okay. So what's that mean? It's a contradiction. There are no solutions. Okay, make sense? All right, have at it. Assignment's up. Go to it.